In part C of section 2, we're going to look at geometric series, kind of similar to what we did when we looked at arithmetic series. Geometric series is going to be the sum of a finite number of terms in a geometric sequence. So you're adding up the terms, and we've got some more formulas for you. And here is the formula, and then we're going to do number 59. So the formula is this, and we're going to use Sn, kind of like we did for arithmetic series. So the sum of n terms in in a geometric sequence, it's a1 minus a1 times r to the n power all over 1 minus r. And this one is on your blue reference sheet. There's a couple different ones there, but you want to use the one without parentheses for these next couple problems. So if you look at 59, we know that the first term is a1, so a1 is negative 2. Okay, and we know that n is 7, so I'm finding the sum of the first 7 terms. So I'm going to go S7, you could call it Sn like we did with arithmetic, but I also need to figure out r, and we do that in a geometric sequence by taking a term and dividing by the term in front of it. So I could do negative 8 divided by negative 2, which would equal 4. So r is 4. Notice if I would have done negative 32 divided by negative 8, I also would have got 4. So we're going to take a1, which is negative 2. You really have to be careful with this formula, and you don't want to do any rounding. So then we're going to subtract a1, which is negative 2. So I'm going to put that in parentheses, times r, which is 4, to the n power. N is 7, so I'm going to put 7 on there, and it's all over 1 minus r, which is which is 4 there, 1 minus 4. So let's do some simplifying here. Okay, you really got to be careful on the top. Obviously on the bottom I'm going to get negative 3, so I'm going to do 4 to the 7th power here first, because I've got to do the exponent first, and that is 16,384 if I take and use a calculator to get that. And then notice I've got to multiply that 16,384 times this negative 2. So I'm going to keep the negative 2 minus, and then when I take negative 2 and multiply it times the 16,384, I'm going to get negative 32,768. Now this becomes plus because it's minus a negative, so be very, very careful with signs there. And so then on the top, I'm taking negative 2 plus my 32,768, and that is 32,766, and we're going to divide that by negative 3, and that should equal negative 10,922. Okay, then let's go down and do 65. Basically the same type of problem. So we're going to do S8, or you could call it Sn, and we do a1 minus a1. So negative 3 minus negative 3 times r, which is 4, to the n power, which is 8, all over 1 minus r, which is 4. It's very similar to simplifying the one I just got done with. I'm going to do 4 to the 8th power, which is 65,535. I'm going to multiply that by my negative 3 here. So on the top, I'm going to have negative 3 subtract a negative, and then when I do that, negative 3 times 65,535, I get negative 196,608. All over negative 3. This turns into plus, and if I take that negative 3 plus that number, I get 196,605 divided by negative 3, which should be negative 65,535.